All right, so you've had a little time to talk with your partners about some of these things. And so what I have ready to go is each of the graphs. I have these graphed on my graphing calculator, then I can just leave them right here. If it's easier for you to graph them on your Chromebook using Desmus, that's okay. You can have it out for this. Make sure you're on just Desmus though. And I'm trying to make this clear. There we go. Just what is periodic might have been a question that you were asking each other. Periodic means that along the x-axis, the y values do the exact same pattern. It doesn't mean it has reflection symmetry. There might be some cool looking graph, but to be periodic, it has to, in kind of the same order, it has to attain the exact same graph after a certain value of x. So I'm going to go ahead and set up my calculator to go from -2 pi to 2 pi. And pi halves, you can do this on using the little wrench on Desmus if you want in the right corner. And I'm going to go ahead and make my y min and y max -5 to 5. Okay, so oops. I hope I graphed them all at the same time. Let's fix this. Okay, first of all, let's make sure I'm in radian mode. If you're not in radian mode, that's not going to work out. And I defaulted my window, and I'm going to fix that again. Undid that. Okay, when I go in here, I'm going to actually just do these one at a time. So I'm going to turn I'm going to just turn these off. All right, so there's my first one, okay? And hopefully you can see it looks like some kind of a parabola, okay? Definitely not periodic. So when I add x squared and assign x, there are some aspects of x squared that I see in that graph. It's kind of on an angle. All right, let's move to our next one. So that one is not periodic. One of these is. Let's see if we get to it. All right, so I'm going to turn that one off. Turn that one on. Okay, now this is kind of cool. This has rotation symmetry if I would turn it 180 degrees. But if it were to be periodic, see how it comes up, comes down, comes to the middle again? It would have to do the exact same thing. It would have to come up, come down. So not symmetry, I mean periodic. This is a no. All right, let's move to our next one. X squared. Okay, wow, that's what periodic looks like. Okay, so this graph is doing the exact same, hitting the exact same y values after a period of time. And it looks to me, I set my period to be 2 pi. It looks to me like if I start at 0 and this is 2 pi, that it takes to here, which would be 1 pi to repeat. So this one is periodic, and it appears that the period is pi. If I ask you to find the period, you do not have to do that algebraically. You may use a graph to do that. The difference between this and this is where the squared is. So on the last one, when we put the squared inside, so that means we're squaring x first, then taking the sign. At first, it looks like it might be periodic. Again, cool pattern. But if it were periodic, it would have to have, like here, started over again and done the same thing from left to right. Okay, so just looking at what it appears or what appears to be periodic is one of the things you'll be asked to do today with a picture of a graph. So today is all about putting other functions with sine and cosine. So here we were doing some aspects of x squared with the sign and doing different things with it. Now, what about if I have absolute value? What does that do to a graph? All right, so you were supposed to graph the tangent and its absolute value, and also the sine and its absolute value. And so the tangent graph, we haven't talked about that yet, but I'll put it up there, so it might be helpful to have that. And then I'm going to do tangent in an absolute value. And there's the tangent graph. Okay, that's the first one. And then on top of it, I'm graphing the absolute value of the tangent graph. Okay, so the first one was tangent, and it went to, like, these almost looks cubing almost, and it's repeated, definitely periodic. And then the absolute value only graphed it positive, which makes sense because absolute value takes negative values and outputs positive values. So this just looks like it is positive values of tangent of x. I wonder if it's going to be the same thing with sine. Sine should be a little more familiar to you because we've spent quite a bit of time with that. So let's take a look at that and what you should determine. There's our sine function. And once again, it takes the absolute value, takes any value that was negative and it turns it to positive. So it's going to give us just positive values of the tangent of x and sine of x. From both of these, looking at the graph, I'm not going to go back to tangent, but I had you set your window negative 2 pi to 2 pi for a reason. And the reason being, then I can, and I messed that up because because I took it off again. The reason being, because then I can see where, if it's 2 pi, where pi is, because a lot of these are going to have periods of either pi or 2 pi. Okay. All right, so once again, this looks like here's the absolute value was graphed in red. The absolute value repeats after a value of pi, so the period of each of those appears to be pi. Okay, finally, the last activity, I asked you which appeared to be sinusoids and why, and granted I'm not here, so then this gets a little more tricky, so I'm going to kind of lead you through this. First of all, you might have wondered what a sinusoid is. I've told you in class, that doesn't mean you remember. A sinusoid means it's some transformation of the sine function, or I suppose it could be cosine function. And so on my board up at the front on the graph paper part, I have this left here for you. We know that, in other words, I could write a sine function that matched this. Once again, we're going to run across some things that have some nice patterns, but are not sinusoids. All right, let's take a look. First, we got 2 cosine of x plus 5 sine of x. This definitely looks like it's a sine. It's stretched pretty high. And so this would be a yes. This appears to be a sinusoid. You can always zoom out a little bit if you're not sure. Let's try the next one. We have cosine of 3x plus sine of 2x. Okay, right away I'm noticing that this amplitude is moving around and doing all weird stuff. If it's a sine curve, this amplitude should be consistent throughout. This is actually a periodic function, but is not a sinusoid. All right, we've got 2 cosine 4x plus 4 cosine 2x. Okay, so once again, cool looking pattern, but this does not look like a sine function. There's no consistent amplitude. It's again periodic, but not a sinusoid. And finally, let's look at the last one. Okay, so here's another one that's a sinusoid. If you wanted to zoom out a little bit, we could. So you can see a little better, but that's definitely looking like a sine curve. So while you were waiting, I wondered if there was anything that you noticed about these functions and why, or what was in common about the two that were sinusoids. And so I'm going to just point out to you that what's consistent in number 1 and 3 is what's inside the cosine function or sine function. They could be, oh, that one wasn't. Sorry. Number 4. What's inside the parentheses is what mattered. It doesn't matter if the functions themselves are the same function, but the b value, what's inside or next to x, has to be consistent. Like on this one, b is 1. In number 4, x over 2 is the same thing as like 1/2 x. And so b is 1/2. In order for something, when we add it together, a cosine and a sine curve, to be still a sinusoid, still a sine curve, that is the key feature, that the b values have to be the same. In addition to that, what you should be able to do is use your calculator to graph and find an equation for. Okay, so I will ask some homework questions where you're asked to take a function that's added together and write it as a single sine function. So let's rewrite number 4 as a function y equals, or f of x, a sine quantity b x minus h plus k. All right, so basically I have to figure out a, I have to figure out b. None of these have a k. So the ones, there's not going to be a k behind them. So it's going to be just a, b, and h. So there's not going to be a vertical shift on these. A and h we're going to do on a graph. So you can look at Decimus or on the graphing calculator. I'm going to show you how. B, remember I told you B had to be the same to be a sinusoid. So you're not going to get B from the graph. You're going to get B from the equation. So we're using example 4 here. This is sine of x over 2, or 1/2 x, minus 2 cosine of 1/2 x. So what is B? B is 1/2. So B in my new sine equation is going to be 1/2. So go take that and deal with that first, or grab that first from the equation. Next, we already have this graphed. So let's go ahead and look. This is the question number 4. So if you don't have it graphed, go ahead and graph it in your y equals or in Decimus. I am going to go back and zoom back in again a little bit. So I'm going to go negative 2 pi to 2 pi halves. And then I'm going to make this like negative 5 to 5. Okay. So how do we find A? Well, A is the height of the wave, okay? And so the height of one wave is from the middle, which is the x-axis, because there's no vertical shift, to the top. And so what I'm going to do is I'm going to use the maximum function to figure out where the height of that wave is. So I get into my calculator, second trace. I selected a maximum. I get to the left. This should not be new for you. And if it is, then you're going to get on to Decimus. All right, so my maximum is 5.355. So that becomes my amplitude. 5.356 actually, if I round it. And even if you can't see that, you should be able to see it on your own screen. So then I move on. That was my A. My B I grabbed from the equation. And then the phase shift. So basically, watch where my pen is here, the sine typically crosses right here. But it's shifted over. So we're going to find, and you could go either direction, except I can't go this one's going down. So I need to find a spot where it looks like the sine normally looks at 0, 0, and it's right here. And I'm going to find that value. So I'm going to go to my menu again. Second calculate, so second calc, and this is called a 0. And I need to get to this is my 0 right here. I need to get to the left side of my 0. Hit enter. The right side of my 0. I hit enter. And back to the middle. This 0 occurs at 2.214. Okay. Now, when we're all done, what we want to do is we want to make sure that my new sinusoid matches that. So I'm going to go ahead and rewrite the equation, and I'm going to graph it in a different line as this, and just make sure that it traces over. So we have 5.356 times the sine of 1/2 times the quantity x minus 2.214. So I'm going to go ahead and plot that in my y2, which it looks like is going to show up in red. Oops, something happened. Did I write down it was a 3? Oh man, Miss Comrie. All right, it's like I'm actually here. Let's go back to this one. I must have written my maximum down wrong. All right, let's go back. You might have caught it while I was doing it, or you might have been on your screen and thought, that's not right. I think I wrote down the x value instead of the y value. Yes, I did. The y values should be the amplitude. So this should be 2.236. Sorry about that. 2.236 rather than 5.356 because we want how high the amplitude is. All right, let's go then and fix our amplitude right here, and that should do the job. All right, so there's my sine graph from question 4. Now in red, you see that we graph right over it, so it's a perfect match. And so you will be asked to do that in the opener today, or the homework today.